Hello everyone, hope you guys are doing well. So this week lab is writing Lewis symbols and Lewis structures. Okay, I hope you would read this background information and also all this information given to you, so you can read it leisurely and try to understand all of this. I will go ahead and help you how to do the problems given here. Okay, so the first few ones are very easy, as you can see. It is asking you to write the Lewis symbol. Fill in the space in the following table with the Lewis symbol for the third period elements listed. So basically Lewis symbol is you write the atom symbol and then how many valence electrons that atom has in the neutral form. Okay, so if it is a neutral atom, but if it is an ion, we can consider the number of electrons in an ion too when you are writing a Lewis symbol. Now sodium, and how do we find the number of valence electrons? For that you have to refer to the periodic table. So your periodic table okay, so let me show you the periodic table. You all have access to the periodic table. So this is the periodic table. So we have groups. So there are 1, 2, 3, 4. Okay, let me show you the main groups. So there are main groups, and also there are some transition elements. So main groups are going to be, so this is group 1, and then you can have, this is group 2, group 1, 2, and then 3, 4, 5, 6, 7, 8. So these are main groups. So in these main groups 1, 2, 3, 4, 5, 6, 7, 8, they have valence electrons, and the valence electrons are equals the group number. For example, group 1, all the elements in group 1, meaning this column right here, they have 1 valence electron. And then the group 2, that column has 2 valence electrons. And then the group 3 has 3, 4 has 4, 5 has 5, 6 has 6, 7 has 7, and 8 has 8 valence electrons. So by referring to the periodic table, we can find out the valence electrons. Now if you want to write the Lewis symbol for carbon, so carbon is in group 4. So you write the carbon, which is the symbol, and then the number of valence electrons are 4 because it's in group 4. So you write 4 electrons surrounding that. So that's what you need to do when you are writing the Lewis symbol. And if you want to write the Lewis symbol for sodium, sodium is in group 1. So it has 1 valence electron, so sodium, and then you put 1 electron. So that's how we're going to write the Lewis symbol, okay, for the elements from the periodic table. So you have to refer to the periodic table time to time to see what are the valence electrons. Now here, let's look at our first one. So likewise, you should be able to write the Lewis symbol. For example, just like we talked now, for the sodium, it would be, you're just adding 1 dot surrounding sodium. Magnesium would be 2 dots. And then the aluminum would be 1, 2, 3 dots. You put the dots on each side of the atom, and then if you have more than 4, then you can start pairing them up. And silicon is in group 4, so 4 valence electron, and phosphorus is in group 5, so you can refer to the periodic table. So 5 would be 1, 2, 3, 4, and then 5. So the last one you can pair it up, and then when you are pairing, it doesn't matter which side you put the pair. So you just put pair like that for phosphorus. And then the sulfur is in group 6, so for the sulfur you add 1, 2, 3, 4, 5, 6, like that. And for the chlorine it would be 7, so you put 1, 2, 3, 4, 5, 6, 7. Right? So you, that chlorine didn't come out nice. Let me write over here. Chlorine. 1, 2, 3, 4. Start pairing up. 5, 6, 7. So chlorine Lewis symbol would be like that. And then the argon is already drawn. It's in group 8. So you put 8 electrons. Okay. So that's how you write Lewis symbol for elements in the third period. Number 2, write the Lewis symbol for each of the following ions, like magnesium ion. So when you are writing an ion, if it is just magnesium element, this is how you're going to write magnesium. And how do you make a magnesium ion? Basically, when you are making a magnesium ion, you're going to lose these 2 electrons magnesium has. When it loses electrons, so then the Lewis symbol will become, it has 2 electrons but it doesn't have these electrons anymore. So you would write like this. But by losing 2 electrons, magnesium will become +2 charge. So then the magnesium ion would be magnesium +2. That's how you write magnesium ion. Okay, magnesium will become +2 charge. Now, how do we get this +2? Like, let's see magnesium in the periodic table. Locate magnesium in periodic table and you will see magnesium is atomic number 12. Magnesium is atomic number 12, meaning it has 12 electrons. It also has 12 protons. Atomic number 12. Now, from this, valence electrons are 2. So right now there are 12 electrons mean 12 negative charges, 12 protons mean 12 positive charges. Magnesium, when you draw the Lewis symbol, it would be like this. Right? It also has 10 co-electrons, and then with these 2 valence electrons it would be 12. But now it loses 2 electrons. It loses these 2 electrons. So then the magnesium will look like this. If it loses 2 electrons, what would be the number of electrons magnesium going to have? It had 12. Lose 2 electrons. It lost 2. Now it has only 10 electrons, 10 negative charges. Did we do anything to the protons in magnesium? No. 12 positive protons. Now what's the difference? 12 plus negative 10. That would give magnesium a +2 charge. So by losing 2 valence electrons, magnesium will have an overall charge of +2 because now it has only 10 electrons, 12 protons, 12 minus 10, +2. So magnesium, when it forms an ion, it forms +2 charge. Right? So the magnesium will become Mg +2. Mg +2. I'm going to rewrite it here. It would be magnesium +2. Magnesium ion would be magnesium +2. Because always it is the valence electrons that's going to lose or gain, that's going to lose when you are forming an ion. Okay? Okay. Magnesium ion would be Mg2+. And then the argon. It doesn't say argon ion. So how do you write Lewis symbol for argon? Argon is in group number 8. So group number 8 in the periodic table. So you draw 8 valence electrons. 4, 5, 6, 7, 8. That would be argon. It's already been drawn here as well. And then the next one, iodide ion. Now let's draw iodine. Iodine is in group 7, right after bromine. In the group 7 you have fluorine, chlorine, bromine, iodine. So iodine is 1, 2, 3, 4, 5, 6, 7 iodine. When it says iodide ion means it has gained an electron. So to make it an octet. So when you gain an electron, it become negative charge, I minus. Okay, now it has one electron more, making iodide I minus. Now same way that we found the charge for magnesium ion, we can consider iodine is 53. Iodine atomic number is 53, meaning it has electrons, meaning negatively charges 53, protons 53. Iodide means it has gained an electron. If we gained an electron, take one electron. So this 53 and electrons are negatively charged. Another electron will make it, the total negative is 54. Nothing happened to the protons. So the net charge of the ion is -1. So when iodide gain an electron, we say it is I minus 1 iodide. Okay. That's the iodide ion. And then the CCM ion. CCM. So we can see where the CCM located in the periodic table. Check your periodic table. CCM is in group 1. Okay. So if I show you CCM, CCM is right here in group 1. CCM is group Y. Okay. CCM is right here. Remember, group 1 has one valence electron. If it is a CCM ion, this is your CCM. When it forms an ion, CCM loses this electron. So it would become just CCM, but it's going to be positive 1 charge. CCM would be CS plus 1. Okay. That is CCM 1 plus 1. That's how you would write CCM ion. CS plus 1. And then the next one, oxygen ion. Oxygen, what is the group number oxygen is in? Which group is it in? Can you refer to your periodic table and tell me what is the group number for oxygen? Remember, I showed you how to number them, the main groups, 1, 2, 3, 4, 5, 6. So oxygen is in group 6, meaning how many valence electrons oxygen has? Oxygen has 6 valence electrons. Okay, so if it has 6 valence electrons, then you will write the Lewis symbol for oxygen would be 1, 2, 3, 4, 5, 6. But what we want is oxygen ion, not the oxygen. Oxygen ion means when it forms ion, it either loses or gain electrons to give an octet. Right now it has 6 electrons. To make it an octet, it need to gain 2 electrons. So the 2 electrons, when it adds up, it's gonna go here. Now you cannot leave it as it is, but now the oxygen will become -2 charge because it has 2 negatives compared to the number of protons. Right? Oxygen has 8 electrons and 8 protons, atomic number being 8. Now by taking 2 more electrons, now it has 10 electrons and 8 protons. So the net charge is going to be 2 minus or 2 minus. So the oxygen ion would be written as oxygen with 8 valence electrons, but also you have to write -2. Okay, that's how you would write the ions. And then construct the Lewis structure model for the Lewis structure model for the following compounds. Construct the Lewis structure model for the ionic compound potassium chloride using the following steps. Okay, so it is asking the number of valence electrons in potassium. So now can you check your periodic table and tell me where is potassium in the periodic table? Potassium would, we're going to construct between potassium and chlorine. So where is the potassium? You will find potassium is here. This is potassium, and then the chlorine is going to be here. So potassium is in group 1, chlorine is in group 7. Again, the group number gives you the number of valence electrons. So you locate that, and then you can use that information here. The number of valence electrons in a potassium ion. So what is the number of valence electrons in potassium? There would be 1. What is the number in chloride ion? Potassium ion is 1. The number in a chloride ion. Chlorine, it would be potassium ion. The number of valence electrons in a just potassium, it would be 1. Number of valence electrons in a potassium, I would say the number of valence electron in a potassium is 1. The number in chloride ion, if it is chloride ion, there would be 8. Potassium ion would be 0. But since it's asking ion, I would say if it is just potassium, there would be 1, but potassium ion would be 0. The number in a chloride ion, chlorine is 7. By taking 1 electron, now it has 8. Write the atomic cores for potassium and chloride ions. Atomic core would be potassium, and then the chlorine would be Cl. Ions, write the atomic cores. Just the core would be potassium and chlorine. Write the Lewis symbol for each ion. So the Lewis symbol for each ion would be potassium. Since potassium ion doesn't have any electron, there would be K plus 1, and then the chlorine would be minus 1 with 8 electrons. Because it has, chlorine has 7, by gaining 1 become chloride, K plus 1, Cl minus 1. Write the Lewis structure for the ionic compound potassium chloride in the box. So then the Lewis structure would be potassium plus 1 in parenthesis and then the semicolon, and then you have chloride Cl 1, 2, 3, 4, 5, 6, 7, 8, put square bracket minus 1, and then you put wiggly brackets, just like your textbook says. Potassium plus 1, and then chloride Cl minus potassium chloride. Okay, and then how does the written Lewis structure for potassium chloride differ from that of hydrogen chloride? So hydrogen chloride is a covalent compound. Hydrogen is in group 1. It has 1 valence electron, and then the chlorine has 1, 2, 3, 4, 5, 6, 7. This is chlorine. So then the hydrogen chloride would be, since it's a covalent compound, hydrogen and chlorine going to share electrons. So the 2 electrons would be shared, and it would be like this. So chlorine has 2, 4, 6, 8, and then the hydrogen has 2. Okay, so this is the hydrogen chloride. And then the next one, construct the Lewis structure model for the covalent compound hydrogen sulfide using the following steps. Okay, the total number of valence electrons in the 2 hydrogen atoms. So each hydrogen will be in group 1. So group 1, hydrogen is in group 1, which is the first atom in the periodic table. It has 1 electron. For if it is 2 hydrogen atoms, it has 2 valence electrons. Sulfur, if you refer to your periodic table, sulfur will be in group 6. So then it has 6 valence electrons. So the total number of valence electrons, 8. So when you are writing the Lewis structure, we only take into consideration these valence electrons. So you're gonna distribute these valence electrons in your Lewis structure when we are constructing that. Okay. Write the atomic cores for the hydrogen atoms and the sulfur atom in the space below. So hydrogen, the core would be hydrogen atom, sulfur atom. Rewrite the cores. Now put pair of electrons between hydrogen and sulfur atom. Hydrogen, there are 2 hydrogens. Hydrogen, sulfur, hydrogen. You put 2 electrons between them, because we need to have bonds between hydrogen and sulfur, and then these bonds, each bond consists of 2 electrons, and now we have put 4 electrons. That 4 electrons came from these 8 valence electrons. So since we have used up 4, there were 8 valence electrons, we used 4 and then 4 left. Now we're going to put this 4 either on hydrogen or sulfur, giving them an octet. Hydrogen doesn't need octet, it would resemble helium configuration, 2 electrons. It's a duet rule. But for the sulfur, we need to have 8 electrons. For right now, sulfur has 4 because it's a covalent compound and they are sharing electrons. So the Lewis structure is going to be H, S, H. Hydrogen doesn't need any more electrons. There are 4 left. So you're going to put that 4 electrons on sulfur. Now sulfur has 8 electrons. Sulfur's 8 electrons are these 8 electrons. Each hydrogen has 2. This hydrogen also has 2. They are sharing electrons. Okay. And then construct the Lewis structure model for the covalent compound sulfur difluoride using the following steps. Number of valence electrons in the sulfur atom. Sulfur again, refer to your periodic table. Sulfur is in group 6. So it has 6 valence electrons. And then the 2 fluorine atoms. So fluorine is in group 7. Refer to the periodic table, group 7. Each fluorine has 7 electrons. There are 2. So 7 times 2, 14. So the total number of valence electron, 14 plus 6, going to be 20. Arrange the cores for 2 fluorine atoms with the sulfur as a central atom. You put sulfur here, fluorine, fluorine. And then put a pair of electrons between them. 2. So we had 20 valence electrons. Now we used up 4. How many more left? 16 left. Now this 16 we're going to distribute, giving each atom an octet. When we distribute the electrons, we always go for the terminal atoms first, meaning the 2 fluorines. So fluorine already has 2 electrons sharing. So to make it an octet, it need only 6. So you put 6. 3 pairs, 6. So we used up 12 for these. And how many more left? 4 electrons left. And then you're going to look at the sulfur. So right now sulfur has 4 electrons. To make it an octet, it needs 4 more. So you're going to put the remaining on sulfur. So sulfur also now has 8 electrons. So these 8 electrons, they are sharing electrons for sulfur. And then the fluorine also has 8 electrons. This fluorine also has 8 electrons. Okay. Okay. Write the Lewis structure for SF2. So SF2 then is going to be what I have just drawn. I just showed you the process of how to put the electrons. So that is SF2. Okay. Number 6, construct the Lewis model for the covalent